Okay. Okay. Is it clear? Let's make sure that this is clear because we're gonna build on it in a bit. This is clear. So we create a context, the function. Once we exit the function, the context disappears from the memory. And the variables defined with that context are not accessible anymore. Unless you return it. Okay, so I'm just gonna remove this. Now here's a concept that also would be new to you, not present in Java. That is, you can define a function within a function. Okay, so we can define a function, and then inside the function, you define another function. Okay, so here we're defining raise to power and takes an argument that is the power that we want to raise to. And then inside that function, we have another function called power helper. Okay, and then within that function, there is a result. Like it calculates the power, just multiply the given value by itself as many times as the power is. Okay. Now, where would this function be accessible? Would it be accessible outside of the raised to power? No, because the function raised to power creates a scope. So the function that is accessible, created within it, only accessible inside of it. So if we want to call the power helper, we have to call it inside the raised to power. Okay, let's try this out. So I'm gonna comment all this out here. Okay, so I'm gonna define a function, raise to power, that takes just the power. Okay, and inside of it, there is another function. You know what? I can make this. Inside of it, there is another function called power helper that takes the actual value and do all the calculation for the power. So you know, when the power, we are multiplying the value by itself in order to calculate the power. So we prepare the variable to accumulate the product, and then for P or I, this is just a counter. So range of power. Okay, so this is to iterate as many times as the power is. And then what we need is just result multiply equal value. Okay. And then it would return the result. Okay, so this part is the function definition, the inner function definition. Okay, how do I call this function? So let's say I am outside, I remove the indentation, so now I'm inside the raised power as well. You think I can call power helper from here? So say 5. I can't. Why? It's not defined. Now we're trying to call power to helper from outside of the scope in which it was created, right? So that's not permissible. I can only call it from the scope. So let's say within the raised to power, I'm gonna call it and return its results. Okay, so in that case, it doesn't give me an error because it is visible in this context. Now, when we follow the function name with parentheses, means we want it to be executed. Okay. So I'm just gonna put this in 2 steps so that we can see what's happening. So R equal power and then return R. Okay, now I'm gonna try to so let's say P equal raise to power. And at this moment, it just takes what the power is. So I want to raise to the power 2. And currently, we can only raise 5 because this is the 5 is the value that we sent in turn. We're going to fix that in a bit. It's just we're building up to something. Okay, so let's see what happens when we try to execute this. So right now we are about to execute the raise to power. Now, is there anything here called result, or is there anything here called power helper currently? No, not yet. Okay, now we're gonna step inside the function that's called raise to power. Inside raise to power, there is a variable called power that is currently equal to, that is the value we sent here, right? Now we are about to define the other function that's called power helper. At this moment, it doesn't exist yet. We are about to define it. So when this function was defined, in the surrounding context, there was something called power that equaled 2. Okay? So at this moment, the power helper is defined, but it's not executed. It's just a function that can be executed, but at this moment, no execution. Only in line 8, when we use a function name and followed by parentheses, that we call this function for execution. Okay? I'm gonna step inside that execution to see what's happening. So step into, now see what is happening. It still can access power because power was in its surrounding context. And now it has a new variable that's called value. And we are about to add result as well. And then we're about to add P. And then the calculation of the results happens. And now we are about to exit from the inner function. Okay, so in the context of the inner function, there was a variable called P, and there is a power that was accessible from outside, and the result and value. Now we are about to exit, right? So that inner context will be discarded. And we only back to the fact that we only just have a variable called power that was equal to 2, and a variable called R that is 25 now. Okay, and then we exit from here. Now we go back and the P would receive what returned and printed. Okay, is it clear what's happening here? Okay, now what if I wanted to raise 5? So still we fixed with 5, but we want to raise 5 to the power of 3. So what would we do? We call the raise to power, but we send an argument is equal to 3. Okay, now we're gonna go quickly to what is happening here. So we are about to enter raise to power. I step inside of it. Power helper is not defined yet. So we see there was a definition for power helper during the previous context, right? But when we exit, that definition also was discarded. So at this moment, we are creating a new context in which there is no definition for power helper yet. Yes.
So this doesn't have.
No, we're not defining global variable. Well, P would be global, but inside the raised to power, we're not talking about global variables here. We're just trying to understand how the inner functions work. All right. Now we are about to create another definition, different than the one we used before. that is going to be created when the power was equal to 3. So that another definition for the power helper is created when the context was 3. When you step inside of it, it knows that the power was equal to 3 and it operates based on that knowledge. Okay? Now the fun part is gonna start in a bit. Now we don't want to only fix it to 5. We want to use this power, raised to power, we want to use this power helper outside so that we can raise different values. So in addition to the fact that we can define a function inside a function, we can return a function from a function. Now, it is clear that when we return a value here, is there any confusion about returning a value? We're returning a value here, right? Just like we return this value, we can return the entire function altogether. Okay, how would that be? So we just use the variable name that is the function name. Without the parentheses. So whatever is defined within this variable is what we are returning here. Now, that happens to be a function object. So code is encapsulated in an object that can be passed around as if it was 5 or 3, as if it was a number. Okay? So function in itself is an object that it can be treated as a value. Okay? Now, before we step inside, let's see how does it look like from outside when I'm gonna leave this as it is and try to print it.